whether it's solar, biogas, wind, what is this other one where they have the catalyst with water and hydrogen? Please help me, ladies and gentlemen. There's one that's called where they put water, hydrogen and water through a catalyst, they get energy at byproducts. Fuel cells, there we go, well done. Excellent, that's another means to look at reducing CO2 emissions. So, the scientific consensus is climate change is really, I could say indirectly but directly also, attributed really to man-made factors. Man-made factors in terms of carbon emissions. They have contributed to climate change. And ladies and gentlemen, we can't get past that. To what degree? There's a lot of debate on that, but there has been an effect, especially in the Industrial Revolution. So, this climate change, of course, we have seen average temperatures around the globe is increasing. We can see weather patterns are changing. I mean, in South Africa, we have had a 3-year period of drought, and now suddenly we have all the rain in the world again. It just does not make sense, especially when it comes to farmers. You know, how do farmers plan if the weather patterns are changing so radically? And of course, recent research in 2018 says that these changes are also bringing about public safety hazards. See, threats to public health. And I mean, if you can think of the cyclone, which we mentioned just now in India, I mean, that's a threat to public safety. So it is then critical that more sustainable renewable energy systems be deployed to try and reduce this carbon emissions. And one of the aspects of these renewable energy systems is, of course, monitoring. We need to monitor them. Are they producing what they should be doing? Are there energy losses? How do we optimize such a system? So energy monitoring, there's a definition. I'm not going to read it to you, ladies and gentlemen. We are more or less familiar with it. Just these three here at the bottom are important. There are various reasons why we would do energy monitoring. I focus on the bottom three. Effective intervention to minimize energy losses. Many systems have losses, which we just seem to forget about. And ladies and gentlemen, that cannot work. We have to identify a loss and rectify it so that our system runs at optimum and so that we can improve our return on investment of a system that is being installed. A second thing is for quality assurance purposes. And the third thing, or the third reason, is to confirm a design of a system that wants to be installed. Again, a confirmation of designs are usually done via simulation packages. That's usually how our PV system is designed. We don't design a system, go and put it up because it costs millions of rands or dollars, and now we go and see how it works. No. We first do the simulation, which is true. But the simulation needs to be verified, as we mentioned in our earlier presentation. So we have expensive hardware requirements. Some of your top-end energy monitoring systems are very, very good. We need to state that up front. But they cost thousands of US dollars, and especially in Africa, we're not going to get to those costs. We're not going to be able to purchase it. Africa, unfortunately, is still a poor continent, as is some countries in Asia, as is South America. I mean, they are some of the poorer countries. So we have to look at cost-effective means of bypassing that. And so we're looking at the use of the ESP-A226. We want to determine the output power of a bigger solar system, and we're going to measure the ambient temperature at the same time. So we have real-time empirical results, but also if the system runs over a period of time, we now have historical data, which we can now also then use, and we can compare that to climate change and see what is happening. Is really climate change having a major impact on our renewable energy systems? These are just three basic microprocessors that are available, which I consider to be cost effective. You have the Raspberry Pi in South Africa, it's about $50. You have the Arduino Uno, and then you've got my ESP-A226, $7, which I think is not too bad, very cost effective. However, we need to increase the analog measurements on it because I only got one analog input port, so I can only do one temperature measurement, but I need to do current and voltage if I'm going to do power. So I just buy an ADC, it's about $5. So what's 5 plus 7? It's about $12. And I've got my system. I've got my remote energy monitoring system, which can be deployed. Now I just need to connect them all, of course, and program the ESP-A266. Just some little programming involved. I myself am not a fan of the Raspberry Pi. Some are. A lot of research has been done on it, and it's used extensively in education. I prefer these two, especially the Arduino Uno. In South Africa, we use it a lot in teaching students design projects. One of the reasons why is it's